Summation notation. The sum of the first n terms of sequence is represented by, where I is called the index of the summation, n is the upper limit summation, and I, whatever that is, 1 is the lower limit. So, the idea is you have this symbol, right? Greek letter. What?
Sigma.
Sigma.
Sigma. Yeah.
It's capital. Okay? That tells you, whenever you see that symbol, I do not have to do anything else. I do not have to tell you anything. It tells you, add all the pieces of the sequence. Sum up the sequence. No instruction is necessary. A lot of times we'll do n or k. In this case, they're using I right here as an index variable. But we tell you down here what to start with, and at the top it tells you what to end with. So that's what they talk about, the lower limit down here at the time. The lower number tells you where to start, the upper number tells you where to stop. So I could say start with the first term and go to the 5th term. I could say start with the 18th term and go to the 23rd term. So you have to pay attention to where they're starting and stopping. So you'd find the numbers in the sequence, and then at the end you add them up. Pretty straightforward. So, start with the first term, is what it's telling you. So what happens? I get 3 times 1 plus 1. What do you get? 4. What's the next number? The next number is 3 times 2 plus 1, which is 7. The next one is 3 times 3 plus 1. And the last one is 3 times 4 plus 1. So it's really these numbers right here. You know, this is your sequence, right? You're supposed to be adding those up. That's why I was putting plus between everyone. What's 4 plus 7 plus 10 plus 13?
34.
I don't know. I thought I heard something.
No.
That's a 34. 11, 21, 34. Got it? That tells you where to stop. So you're going to write down your first term, your second term, your third term, and when you get to the 4th term, stop. So, yes, that's what it means. So here is your rule to find terms. How's that look, Wyatt? Does that look good? Can you read that thing? Gotcha. This, though, is the most important thing. Sum. So the summation notation is giving you a rule to find all the terms, but the summation itself is telling you turn around and add them all up. So with somebody sitting near you, you're going to do part B. Now, what's this negative 1 to the I minus 1 power doing? All it's going to do is go from a negative 1 to an odd power, negative 1 to an even power. Negative 1 to an odd power, it's going to just oscillate, right?
Yeah.
Okay, so with somebody near you, do that. I factorial. So, how many terms are you going to write down? 5 terms. 1 to 5, and then turn around and add them up. Okay, so the answer turns out to be 101. Please. So, negative 1 to the 1 minus 1 is really 0. What is negative 1 to the 0 power? 1. 1 factorial is also 1. So what I'm doing right here is I'm writing down the two things that are happening each time, and then you're multiplying. So the very first term would be a 1. Then in the second part, I'm showing you how I did -1 to the 2 minus 1, which is really a 1. So what happens when you take -1 to the first power? You get -1. 2 factorial is 2. My second term is -2. -1 squared, because 3 minus 1 is... So you get an idea, positive, negative, positive, negative. I turn around and add them all up. Third term, fourth term, fifth term. I get 101.